Now what we can go ahead and start creating our top network. So let's go inside our HDA, and I'm going to start by creating a file pattern node. So file pattern node creates creates work items from directory path pattern, which means that we give a path to a directory on our computer and use wildcards to determine which files we want to fetch from that directory path, and it's going to create work items from that pattern. In my case, I want to get basically my textures. Basically, I want to get any files from my main directory parameter. So what I'm going to do is go ahead and copy this path, copy relative reference, and paste it inside here. And what we can do now is basically say / to find all files inside there. And I'm currently pointing to one of my textures that's inside here, like that. Go ahead and cook this file pattern node. You can see it has found every file inside that directory. All of them are JPEG files except for one JSON file that comes with the Megascans texture set that has a bunch of metadata about this texture set. So yeah. And to make sure that what I'm going to do is start copying some of these sticky notes that are going to explain a little bit more about the attributes that I want to set for initially set for every work item that I fetch from file pattern nodes, so that I can go ahead and have a constant attribute between the both modes of fetching of data. So I have a single and batch mode, so I want to do a little different operations on both modes. So let's start by handling the single mode. Single mode is going to be files only. This pattern is fine, and then the file attributes is also fine, except I want to rename my directory attribute as a root directory. So I'm going to call this directory attribute to the root directory, because this root directory is going to be path provided in HDA directory parameter. All textures will be sourced from here, and that means because there could be a chance that our root directory is actually different. Root directory will always be basically same for both batch and single mode, but the set directory is actually going to be different for those two modes, because of the set directory is directory path where the file is located. So you can imagine if you're having a batch mode, our root directory would be this one, because our parameter points to this path, but the set directory would be subfolders of this root directory. So the set directory would be a path to these subdirectories. So this is where I want to create two different attributes for them. But since this for the single mode, my root directory is going to be same as a set directory, I want to go ahead and basically just copy create a new string, create new file attribute on the work items, and I just want to go ahead and reference the p at root directory attribute as a file path. And if we copy it, if we generate it, you can see it has basically copied these values. Now our root directory is the same as set directory. And one thing to note, that how I am referencing these top attributes inside parameters, I'm using the p in front of it. So this is basically says that this is a PDG attribute and not a geometry attribute. So the p in front of it is optional, but I always use it to denote that this is a top attribute. And now I want to handle the batch mode. So let me copy this file pattern node. Inside here, what I want to do is go ahead and set the file types to directories only. Let's generate this again. So right now I'm not generating anything, because the directory we are pointing to, it has no directories inside it. So let me delete the last part of the parameter, Let's generate it. Now we have all of our directories. And one thing I want to do is change the attributes that we are generating from this pattern. Since we are not going to use file names of the directories and file names and extension, and I want to go ahead and root directory is correct. And I want to go ahead and create a new file pattern node, and inside here I want to reference the input file PDG input attribute for this node. So the PDG nodes has a concept of input and output files. So by default, you will see that this file pattern node has created an output file that we can reference in any node that this node is going to connect to downstream. So the output file for this node is going to be the input file for a node that it is connected to. So this is why we can go ahead and say p at pdg input is going to basically return the string value of that path, and we basically match everything again. And you can see that we have fetched every file inside every directory from upstream. So these are the file name and the JSON files also. So that's good, and I want to make sure that I set my directory attribute to my set directory. So this is where the values of the set directory will change based on the mode. And let me go ahead and copy a couple of more sticky nodes to kind of tell more about, and you can read up on them to see what we're actually why we're doing a couple of things that we're doing here. And I want to go ahead and create a switch node. I'm going to select both of these, and I want to reference the mode parameter inside here. So we have selected our mode, and one more thing that I want to handle is ability for an edge case when the initial file pattern node would fetch incorrect work items if our parameter in our HDA is empty. So with this, let's try this out. So let me say I delete this directory parameter, and I go ahead and recook this node. You can see it still created new work items, but you will see that these work items are actually it's kind of hard to know where they are. These are basically the root directory. Basically, these are the directories that are in the root of the hard drive where the heap file is located. So this is not useful for us at all, and we want to make sure that we do not fetch these work items since they are not useful for us. So this is where the expression comes in handy. So we're going to use the if-s expression function. It's going to return a string value of the second or third argument depending on the truth of the first argument. So you can see that if-s, the expression is going to return either 0 or 1. So 0 is false, it's going to return the true value, and the false is going to be the third argument. And to do this, we're going to use a string comparison expression function, which compares two string values. So we want to compare our directory parameter string with the empty string, and if these two are the same, it's going to return a 0. And if we say that if this is and let's say we use a equals 0, it's going to return true, and that means it's going to return the second value. So let me go ahead and copy this expression and walk through the expression. Make sure that you put it as a string value. I'm going to copy it, then I'm going to apply it. You can see if-s, this is the expression that we check for, and basically comparing parameter with empty string. And if this is 0, that means that this is a 0 and it's going to be a true. That's going to return an empty string. And if it is a false, it's going to return the last one, which basically means that right now, if we cook it again, we are not creating any work items because we are providing an empty string to this parameter. So this is exactly what I want to make sure that I do not create incorrect work items. And this is basically it for the setup of initial fetching of texture data. So I'm going to put some what are they called? Letter boxes around these, and let's actually use the same expression function inside here too. And further on, I'm going to use the single mode, because that's going to give us only one single texture set, which is going to be a lot easier for me to work with. So let me paste this inside here. Let's put it on a single mode. Let's generate these work items. Okay, so I have now switched to single mode, and that's good. And anything after that is going to work just as fine with the single or the batch mode. All of these work items that we have fetched are not at any way filtered. So I want to make sure that now I want to implement the HDA's abilities to select only the extensions from our HDA parameter extension parameter. So you can see basically we have all of these are JPEGs except for the one JSON. So I would like to remove anything that's not in the list of valid extensions. So this is where the Python processor node is going to come in handy. Let's connect this. Let's cook it. You can see by default it has some template code. It's basically going to create new work items from the upstream items. So, but we do not have to return all of them. We can basically implement custom logic for returning work items that we want. And this is where I'm going to go ahead and implement another helper function inside my Python module. Let me open this up in Python in external editor, and the function that I'm going to write is going to wrap around the item holder and upstream items variables that are available inside this Python processor node. So item holder is basically the object that we have to add our work items to, and you can see in template code item holder dot add work item, and you see that by default it basically just adds every upstream work item to back to the item holder and going to create these work items. And then there's an upstream items, which is like a list of all of the work items that you want to loop through. And let me open this up here. So the function that's going to be is going to be wrapper for Python processor node inside top network that filters upstream work items by file extension. So work item by extension function, we're going to create the parameters for the upstream item, and the item holder parameters we're going to pass to this function, and also we're going to get our extension array, which is going to be called to this we're going to get the call to this function that we created previously. And then we have an ability to invert the result of the filtering. So for every upstream item, I want to get the extension string attribute. So the string extension attribute, and then I want to go ahead and check if we are inverting the result. So if we are not inverting the result, I want to check if the extension is inside the extension array, or if the extension array is empty. And then I want to basically add every one of these work items. So in the case when the extension array is empty, that means that we do not want to do any filtering. That means add every work item. Or if it is not empty, that means we have to check if this extension is inside extension array. So we're going to check it, and we're basically calling the same code as in templated. And for the item holder, we add a new work item. And one thing to note that the work items that are going to be created will not have any output files, and it is very important for us to keep the output file of the incoming work items. So we have to go ahead and add it manually. So the new work item, we're going to add output file, and from the upstream item we call the output file property, output files, we get the output file, and we have a property of the path, which is a string value of the output file of that work item. That's going to make sure that we are keeping our output files. And then we want to go ahead and handle the inverted selection. So if we are inverting, if this boolean is true, we want to go ahead and if the extension array is empty, return no work items, since we are returning all work items when we are not inverting. So if not extension array, basically just call continue. That's not going to add any work items. But if the extension array is not empty, we want to add inverted work items. If extension is not in extension array, and then we basically do the same thing. And that's going to be it for this work items by extension. And if we have set it up correctly, we can go ahead and call it. And the calling of it is very simple. So let me paste this inside here. So we're getting our HDA node. We have to call this self variable that is available inside this Python processor node. We're getting the top node object, which is basically like a top node, which basically represents this node. And then we can traverse this node to get 2 levels up, which basically means it's always going to be our HDA node. We get our extension array, HDA node, HDA module, call the function get extension array, and then get the node to the reference, which is here. And then I want to call the wrapper function. And the wrapper function is again HDA node, HDA module, the function we just wrote. Then we passed our upstream items, item holder, extension array, and inversion is going to be false. And if you go ahead and cook this node, you can see it has dropped 1 extension because in our parameters we are fetching the JPEG files, and all of them were JPEGs except for the one JSON file, and you can see this file has been dropped from the work items. And if we would true for the inversion, you can see we have got 1 work item, that's a JSON file. So for now I want to go ahead and do it as false, but now we have filtered out our data. Let me copy these helper sticky notes. We're going to use across this network, we're going to use Python processor and Python script. And the difference is that Python processor, we can manually create new work items and basically do some filtering on them. And the Python script is always going to return all the upstream work items. This is good for the basic manipulation where we do not need any filtering of work items. And now I want to go ahead and use my regular expression defined in Python module to split my file name attribute into 2 different attributes. So put down a attribute from string node, connect this, and we're going to go ahead and reference our file name attribute. So for source string p at file name. Let's cook it. So we got correctly, source string is correct. And then for the pattern time, I want to use my regular expression that I have defined. Just select the pattern time to regular expression. And for that, you can go ahead and expression edit string. Make sure that you put it on the Python expression. And let me paste this one. So I want to go ahead node. I want to go 2 steps up, get the HDA module, get my array match object that we defined, and use the pattern property on that object because of the array match variable is an regular expression object, and to get the string I have to call the pattern property. And if you apply it, you can see that the pattern is fetched, and if you recook it, you will see that it has a split, it has created new work items, the common name, which is a group inside regular expression, and the type, which cavity, displacement, normal, all of this. And to really to explain everything, I put down a sticky note. We use regular expression from Python module to create common name and type attributes. An optional extension group inside the regular expression is used for flexibility. In top, we match it against the name without the extension, but in Python module with the extension. So now I want to go ahead and set the type attribute value that we got for each one of these textures as a tag for the output files. So you see the for the output files, you can see this grayed out text is basically the tag that we can reference output files with inside our properties inside Houdini. So basically, I want to set its type as a get this type value and set it as its tag. So this is going to be very useful. I want to use a Python script. So let me copy this. Copy this node and this Python script. So remember, the Python script has no ability to filter out any data, and since we have already filtered it out, we just want to simply set the tag value. So we use Python script instead of Python processor node. So inside here, I get the string attribute type value. I get the output file with the parent item output files with the index 0 path. And then if we go ahead and for the work item add output file, we can go ahead and override the this will override the current output file with the same file, but this time we add the second property for this function call, which is the type of the output file tag, basically to add the tag to this output file. And then you go ahead and cook it. You can see that it has added, instead of the old input file old tag, it has taken the type value and set it as its tag. Now that's good. And let me go ahead and copy this also. Use type attribute as a tag for texture files. Now I want to go ahead and create the piece attribute for every texture set that we create. Piece attribute is a combination of set directory and common name attributes. This will ensure that if a common name is the same in different directories, it will be still separated in different partitions. So again, we're doing basically the same thing that we did in our Python code. We want to make sure that our partitions are correctly set up. So you can see that we are creating a new attribute create. I call this a piece attribute, and the value is basically just the reference to the set directory and the common name attribute. If you take a look at it, our piece attribute is going to be this long string of values, which is not very pretty, but it's good to. They're going to make sure that we have correctly partitioned our texture sets. And I want to go ahead and use the partition by piece. Inside here, I just by default use the partition by piece as a piece attribute, and if you cook it, you can see we have from 9 work items, we have one partition, which makes sense because our texture set, we are providing one texture set inside here. And you can see the most powerful thing about this partitioning is that now for every work item we can reference any of these output files just by using their tags. You can see that it has basically combined all of the output files inside one work item. Well, it's called partition, but it's basically the work item. Before we go ahead and create new work items for every texture that we're going to render out, I want to create a new attribute that's going to be used in one specific case. So I'm going to call this a folder ID attribute. So before we fan out our partition, assign a unique index for each partition. This attribute will be used if ensure unique directory name is toggled on. So to explain this, so we have ability to ensure unique directory name. So this could be useful if we have in different directories we have a same common name, and we output our new texture sets into the custom directory. So that would mean if we output into a custom directory, that means that all the outputs would be in a single directory, and that would mean that it would override the basically the newer texture set with the same common name would override the older one. So to cover these edge cases, we can create a new integer value that we can go ahead and append to the end of the newly created directories, if that is something that we are worried about, or that could be the case. So this is a kind of utility attribute. And now what we're going to do is go ahead and create new work items per texture. And this is a very simple thing that we're doing. Let me copy this also. This sticky note. So for each texture set, we create a new work item will be created, and number of new textures are determined by texture parameter. So if you go ahead and open the parameters of HDA, in this multi-parameter I have set up three test textures that I want to render out. And what I'm doing here in this range generate node, basically referencing this parameter f texture parameter. It's going to create these work items for every one of these work items. And if we generate, you can see we have a value range of 3, and every one of these has basically have copied the same work item 3 times. And I call this a texture ID that's going to be created. So this is going to be the difference between, only really difference is going to be the initial index of the work item and the texture ID. So this texture ID would be kind of like for every partition is going to be 0, 1, 2, and if we had multiple partitions, then that partition would also get 0, 1, 0, 1, 2 texture ID attribute. So this is a important attribute for us to have. Up next, we want to set our file names. So this file name is going to be the end file name for the textures that are going to be rendered out. So let me go ahead and explain this. So what we're doing is basically replacing the existing attribute. So we already have a file name, but the file name is the old file name. That's not going to be very useful for us when we generate the new textures. So inside here, let me edit the string. So we are getting our common name, and we append the name of the texture ID, name of the new texture. So this is basically, we are getting our texture ID. So the texture ID is the attribute that we created on upstream, and this upstream is going to represent the multi-parameter block inside our properties parameters. So you can imagine that when we are referencing, we're basically referencing this name parameter dynamically using the texture ID attribute that we created. So basically going to fetch either normal OpenGL, normal DX, and base name for every one of these work items. And then we add the dot in front of it, and then we take a look at the extension. And the method for that is basically the same. We get the extension, we reference our extension parameter and use the p.extension texture ID attribute. And if you take a look at it, if you generate this for every one of these work items, you can see that our file name is now the end file name that's going to be created, which is the common name. the parameter, multi-parameter name value, and then the PNG, and then the extension that we have set also on our HDA. So for each texture set, create work items for all textures that will be created. Number of new textures are determined by the texture parameter. And now I want to go ahead and set my output directory. So this is going to involve creating a new attribute. So this is going to be attribute destination root directory. Attribute will be based on the output to parameter. The source, if the output to the source, the destination root directory will be the same as the set directory. And before the custom, we're going to reference our custom path parameter. So let's handle both of these cases. I'm going to copy both of these nodes and explain. So attribute create, we're going to create a new string attribute, call this destination root directory, and for the value, I'm going to just go ahead and set it as a p at set directory. So you can see that destination root directory is the same as the set directory, which is here. And for the other case, I want to go ahead and reference the custom output directory parameter from the HDA, which would be at this parameter. So let me say cook it. You can see right now destination root directory is going to be full. And I want to go ahead and switch between them. Create a switch. Connect these and reference our output to parameter inside here. Okay, so that works very nicely. And one last thing that I want to create is the name of the directory that is going to hold our new texture sets. So let me paste this inside here. So the destination is going to be called destination directory name. Will hold the name of the new folder that will be created for each texture set. Default name for the new folders are common name attribute value underscored with the name parameter from the HDA. If ensure unique directory name param is checked, the folder ID attribute will be appended. So let me show what this is code. What this code is. We're basically creating two different possible names for our directory, which is going to be based on the whether we have selected this ensure unique directory name. You can see one is just a common name underscore the name of the texture set, which is this parameter, and the other one is basically the same thing with the appended folder ID attribute, which is set from upstream. And then we basically create the destination directory name, and its value is going to be the if-else statement that I already showed, that we already used in texture in that we already used in the file pattern node. Checking these parameters, you can see we are appending if we have a unique directory name, and we do not append if we do not. And now we have set up all the attributes that we need to go ahead and composite our new texture set. And that is going to be done with the new COP network. So see you in the next video.